Hey there! So I wanted to show you this awesome little box I made to control this strip of LED Neopixel lights and make them react to music. So first up on the left we see this USB cord, and that's the cord that connects the box to the LED strip and carries power and signal to the strip. Over on the right side you've got first up an aux cord coming from my computer, and that brings the audio signal in. And actually out of my computer I have this Y splitter here, and so one end goes to the box and the other end goes to the speaker so that the sound you hear and the lights you see are all synced up. Also got power and a connector here for 5 volts power for the LED strip, and this USB port, which is the one actually on the Arduino board, and so it's really easy to download new programs onto the Arduino even while it's inside the box. And lastly, a power status LED, which if I flip the switch up front, you'll see turns on and the lights turn on too. And so this is the first of 12 programs that I have downloaded on the Arduino that change the lights' behavior. And actually, if I flip the switch in the front, you'll see them change. And yeah, so I'll go into that more in a sec. But first, let's open up the box and check out the inside. So here's the system all opened up. You can see the box a little bit better too. So I designed and 3D printed this box so that all the ports and all the switches on the front of the box are nice and flash, and all the components inside bolt down. So you can see inside the main components, the Arduino Uno on the bottom, board with all the solder connections on the top, and in the back, the USB panel mount for the LED strip connection. And the main workhorse of the system, you can't see it because it's on the underside of the board, but it's the integrated circuit called the MSG-EQ7. It's a pretty cool little chip. It takes the audio signal as input and outputs basically a 1x7 array of values that correspond to the amplitude of the signal at different frequencies throughout the audible spectrum. And that's pretty powerful data to have, because I can make the LED strip then respond to the volume of the music and even volume at different frequencies. And there's some pretty cool patterns that I'll show you in just a sec. I also pass the audio signal through a basic amplifier before it gets to the chip. Just in case the audio source is a little bit quiet, I can always get it up to a usable volume here in the system. So let me just button this up. All I have to do is align the notches on the top and bottom of the lid with the base, and then screw it in so it stays nice and tight. So the first two patterns here are both solid. First is solid white, followed by solid blue. Next up, flashing red, where the intensity of the red is determined by the volume of the bass notes in the music. The red RGB value of these flashes is determined by the bass notes, the green by the midtones, and the blue by the high frequency notes. Here, each different colored flashing block corresponds to one of the 7 frequencies measured by the chip. This pattern acts almost like a history mode for your music. The color of the center 3 pixels is determined by the bass, mid, and high frequencies of your music, and this color scrolls away to the outside as time goes on. The large blocks of color in this one slowly change to the beat of the music, better for a relaxed time than a real party. These background colors slowly fade between purple, pink, orange, and white. Now the pattern flashes to the beat too. This pattern is a simple fade throughout the rainbow. After a button push, it too starts to flash to the beat of the music. finally, a rainbow scroll that chases colors from one end of the strip around to the other and back. So that's it for now. I got those 12 programs written, but what's great about this system is that there's really no limit to the cool things I can do with it, and so I'll certainly be adding more in the future. Thanks for watching.